our guest speaker will be Joe Dechene, who will be speaking about this rich field binocular telescope. Now over to the agenda. So, few of you may be, or most of you may be kind of surprised as to why I'm up here. Microphone. So I'm Binocular. Christine Zackler, who was the president, she decided to step down to take care of some personal matters. So she's looking for a job and such, so we wish her well. So I'm here. Just to give yourself a background of mine, I have a background in physics. I did my PhD in particle and nuclear physics. I worked at Brookhaven National Lab for some time, then at CERN. But for the last decade or so, I've been working in the IT field. The only astronomical thing we do is that our company manages an astronomical amount of money. They say that we manage about $48 trillion, and I don't know, they say that if you stack it up, it goes 12 times the distance of the moon. Yeah, for all it's worth. So my son asked me about if I'm a hobby, and he introduced me to a physician friend of his, and he was doing astrophotography. And he had some fascinating pictures, and he had moved to Utah from New England so that he can get clearer skies more often. So I got also interested, looked up ATMoB here, and met folks here, and thanks to Corey and Al, and I took the initial direction of astrophotography. And my wallet has been noticing it since then. So my son asked me which group I joined. I said ATMoB. He asked me, what, Mom? Anyways, now Richard honored me at one of the star parties and said that he was interested in nominating me for the VP role, and there was no heavy lifting. And so I thought I could continue to sit as a member of the audience, but anyway, I'm here. So I look forward to the opportunity here, and thank you all, and thanks Corey for setting the framework of the presentation today.
So here's Glenn's cartoon of the month. Something about an astrologer, right? Do you remember the year at the conjunction when they were going to have an astrologer debate an astronomer? And the poor astronomer had a family crisis and he couldn't be there. But the astronomer, and then the astrology guy got up, and actually, brave as he was, he got up there and did a whole thing on astrology. I'm pretty sure they burned his car out down in the parking lot. It's just like, there was one guy from Pennsylvania who was like so mad at the guy. He was up spinning mad in the middle of the presentation. It was like awful. Anyway, where's Glenn's cartoon? Oh, this is a saying of the month. Scientists say the universe is made of protons, neutrons, and electrons. They forgot to mention, you can fill in the blank however you see fit. So
just flip back for a second. I'm going to comment there. That picture there, I'm going to make a disclaimer. That just happened. That's there every month. It had nothing to do with answer D. So just so you know.
I was going to put an arrow and say not us. Anyway, that's a great shot of us. So as far as the planets go, here's the slide I showed you last month. Is the late 2024, early 2025 Venus apparition, the evening sky, 40 degrees north latitude, and we're right where that red arrow is. And as bleak as that looks, I've been able to see Venus for a couple of nights, clear evenings, low in the west, right after sunset. So it is visible. I was also looking at it, guess what, during the day the other day, so it can be done. But that's what Venus is going to do during this apparition. So not great. You know, the ecliptic runs really low in September, and so it makes it rough for observing. All right, next slide. So Mercury is at greatest elongation west on what was on the 4th. You can see that in the morning sky. The morning ecliptic in September is nice and steep, so this is a pretty good apparition for Mercury this fall. Saturn was in opposition on the 8th. It's at magnitude +6. Transiting about 12:30 in the morning, 40 degrees high, 800 million miles away with a ring tilt of only about 3 degrees. So if you haven't checked it out yet, it looks pretty weird. It looks like it's just got two little arrows sticking out of its sides. If you can catch it in the meridian, up out of the murk and out of the turbulence, it looks pretty nice. It looks pretty nice.
When is the ring plate crossing? Is that next year?
It's next year. There's one in March and there's one late in November. There are a couple of them, and I don't know how precisely edge-on it is. It has to pass through it. I think the one in March the March one is too close to the sun. But the November one should be pretty cool.
That's the best time, by the way, to look to some of the fainter moons of Saturn is around that time, because then you don't have the brightness of the rings, making it more difficult to see things.
Yeah, they look pretty cool. They look pretty cool. If you can get a nice steady night, pretty. Neptune is rising before midnight. Opposition occurs later this month. Triton is at magnitude 13.5 in a decent size, 10, 12 inch telescope. You can see that moon. So I would suggest you go out and have a look at that. Uranus is currently shining at plus 5.7 in Taurus, with opposition on November 21st. I think there are 2 more slides. Mars is, if you could hit the next slide, Benno. Mars reaches opposition in January, but it's a poor one with a distance of about 60 million miles, 14.6 arc-second apparent disk, but Damian Peach has been posting some really nice pictures of Mars already. The disk is small, but if you get up, it's up after midnight. You can check it out. But the real star of the early morning skies is Jupiter, coming up about 12:30. Opposition occurs in May, and when we get closer, I'll start sending out Great Red Spot and Shadow Transit predictions, just so they're sort of in your face, give you the opportunity to go out and see those sorts of things. So that's what the planets are doing. What's the next slide? I can't even remember what I put on the slide deck. Oh, the spike occultations. So Alpha Virginis, blue-white B1 star, magnitude 1, September 14th. That's next Tuesday, maybe.
No, it's Saturday. Saturday?
Oh, it's Saturday.
This Saturday.
Oh, it's this Saturday.
This Saturday.
See, retired. I'm not sure what day of the week it is. The date means nothing to me. So on Saturday morning, just before 11:30, maybe you're at the clubhouse, and somebody's got a telescope pointing at the moon. You might actually be able to see the spike occultation. Bright enough to see in daytime, but the November 27th occultation, just before 5:30 in the morning, will be spectacular. So go out and check that one out. That'll be a really good one to look at. All right, next slide. While you're waiting for that to happen, there's a partial lunar eclipse coming up next week. Maybe this is Tuesday morning, or Tuesday night, the 17th. It's a very shallow, about 9% of the diameter. It's about 3.5% of the area of the moon will be covered by the umbral shadow of the Earth, with the eclipse happening in a reasonable hour.
And not total, Mario.
It's not a total eclipse, right? There's just be a slight dimming.
I only like full lunar eclipses.
Anyway, that's coming up. I didn't want to mention it, but this Saturday is the International Observe the Moon Night, Mario. You may have got a telescope and treat your neighbors to some lunar views. I'll bet that thing looks awesome through the 32-inch scope.
Projected.
So anyway, that's coming up next week. And then there's one more thing to think about up and coming. And this is the real star of the fall. I think it's the next slide, please, is Comet 2023 A3, Tsushinshan Atlas. Currently in the morning skies, and I don't think it's particularly visible, but as it rounds the sun later this month, as it rounds the sun on October 9th, I think it passes perihelion later this month. On October 9th, it rounds the sun, and predictions are if it stays intact on the day it passes, goes around the sun from our vantage point, forward scattering of the dust tail could make it exceptionally bright. And close to the sun, you have to be careful, but if you were to shield the sun behind a roof, you might even be able to see it with your eyes. We're hoping that the second and third week of October, this will be a spectacular comet in the western skies right after sunset. So more on that at the October meeting. And of course, the variable star of the month is T Corona Borealis. Now I've written, instead of July through September, it's September till whenever. And I was just talking to Joseph at the beginning of the meeting, and remember that the last outburst was 1946, with an 80-year period that puts us still 2 years out. Now I know it did a dimming last year, which is kind of the hallmark of an eruption. But let's just see how long we have to wait till we see that.
I did check the data just today, and since the last time we met, it's slowly gotten a little bit brighter. It was kind of around 10.4. Now it seems to be closer to 10.1. So
Yes, about half a magnitude
it's a
brighter.
definite increase, but not by much.
when it goes, I don't think I included the, I don't think I put the slide on there.
Just one day.
But when it goes, it'll be up in a day and then start to come down again. So as soon as I have any information on it, whether I observe it or whether I go on the AVSO site at least twice a day to look at observations, I'll let everybody know as soon as it happens, and get out there and check it out. All right, next slide. So while we're waiting for that, I picked Glenn's favorite double star up there is SS Cygni. It's another cataclysmic variable with about a 30 to 50 day period. Glenn, you can talk
Typically
more to
50
this.
days, yeah, it's 50 days. It's been acting kind of weird in recent years. I know Joe Ross has been checking it out. He's been pretty good with that. And again, the thing that's nice about it is it's visible in a small aperture telescope. I started looking at this star way back when with my little 3-inch Edmund scope. And I couldn't see it when it was at minimum, but I could see the faintest star I could see was about 11th magnitude. And when this star starts to go up, if it hits 11, it's usually going to go the rest of the way up. And when it does, again, you jump from one night you couldn't see it, the next night, and there's like I don't know if it's all 3 stars, there's a triangle of stars. It's at the top there. And it's right in the middle of that triangle. And all of a sudden, there'll be nothing there, especially with a small telescope again. And then you go out one night, and there's an 8th magnitude star right there. So it's really spectacular when it goes. And that part of the sky will be visible right up until around February. So if you haven't ever looked at this star, take a look. At first night, it might take a little time, especially if you're a star hopper. I think the first time I ever looked for probably 10 minutes to finally locate the area. The next night, maybe 3, because you want to look at this every single night. It goes, it's just like the other one. It goes about one day and it's ready to go. One time I did see it on the way up, which is kind of neat. It went up about a half a magnitude before Cygnus set, so it's a great star to look at.
This star erupts because of accretion disk brightings, as opposed to T Corona Borealis, which is the surface of the white dwarf, accretion on the surface of the white dwarf. So this one goes, like I said, 30 to 50 days. It's a fun one to watch. It's pretty easy to find. Although I may not look at it, it's actually, once you know the path to it, it's pretty easy to find. So we just encourage you guys, you folks, to get out there and check it out. It's a fun star to look at. I think the next slide is the double star of the month, which this month I picked Gamma Delphinus. It's a beauty, 4.26 and 5.03, sort of a yellowish, orangish pair, 8.8 arc seconds. It's a pretty easy one to spot. And if for no other reason, you can get to familiarize yourself with Delphinus the dolphin.
And by the way, when you get that star in the field of view, look around, because it's got a companion. There's another star in that same field. It's Struve 2725. And I think the magnitudes are more like 7.5 and 8. That's about 6 sides. It's a little gem. And I just happened to stumble it, quote unquote, co-discover it when the first time I looked at the Gamma Delphini. So it's a great pair of double stars. Same field.
While you're in the area, there are a couple of nice globular clusters here. 7006 is just off of Gamma. And there's another one, I think it's 6345. Is that right, Steve? Do you know that one? It's just below the tail. It's like down here. 2 little globular clusters you can check out.
Yeah.
They're on star charts. I think it's 6345. But those are some nice things to look at in the finest. All right, what's the next slide? Oh, go ahead. You do the challenge.
September challenge is NGC 6822. Confession, I haven't even bothered trying for it. This is Barnard's Galaxy, and it was a notoriously difficult object. I mean, things have gotten a little better with our, we have better observing equipment than we did at the time. I think it was discovered near the end of the last century, and I found that the only way I'm going to look for this if I go to a place like Stellafane. Where I live, my sky is a magnitude 5. It's the limiting magnitude. It's not even worth trying for. It's very faint and large. And it's said that, I don't remember the astronomer, but an astronomer at the Mount Wilson Observatory could not see it with a 100-inch scope. Now that's primarily because the field of view is so small, and this is a big object. But he's able to see it with a 4-inch finder scope. So my tactic, when I finally do find dark enough skies, I'm going to take a little Edmund Astro scan. It's a little 4-inch RFT. Get a medium power. You want a field of view of about 1 degree. This thing's about a half a degree in length. It's kind of oval shaped. So that would be my tactic. Take a wide field, small reach field telescope, really dark skies, and give it a shot. But again, I didn't even try it. And I think we have a couple of images. Mario and Doug Paul. We'll go to the next slide.
Glenn?
Yes.
Move on. That's the preliminary image, not the final image. Could you move back one? Back one slide.
Oh, back up.
Okay. Down near the, you can see a little.
Oh, right here.
Right there. And
That's a pro. We got a better one coming
right,
up.
and near the top there's a planetary.
That's,
Oh, yeah, that's
that's called the little gem.
6818.
6818, that's easily seen in a 6/8" telescope.
Up on top, it looks very good.
Very green, right?
Yes.
Very
Yeah, that's from the oxygen being.
And by the way, that same little Edmund telescope I was talking about, the 3-inch, I've seen it with a 3-inch telescope, so you don't need, large instruments. Just you want a little magnification, because it's about 25 arc seconds across, so it's kind of small.
That's what I was gonna say about that picture. When you can't find Barnett's Galaxy,
Yeah.
right, you're in the neighborhood, go up and check out the Little Gem, because it's a really, really pretty planetary nebula.
I don't know they've done a nest there, but that's kind of neat, a yellow giant right next to that planetary. Looks like a wide alberio.
And that nebula is, I was looking at that just the other night, it was really pretty, very easy. You can see it without filters. Of course, Oxy-Therese UHC will improve the view, but I could actually see it without filters, it's pretty bright. All right, so then we'll go back to the slides of the galaxy. That's very nice.
By the way, just those red blotches, those are not artifacts. I'll let Mario explain that image.
Should I go back?
Well, in Loom, you can see them. Go back in, whatever. In Loom, you can see them. So I decided I'd do red, green, blue. I forget, it was 45 minutes each of those. And then I went for H alpha in order to bring those out and overlaid that on top. Because look at them, there are huge numbers of H alpha regions in such a small, irregular galaxy. Blew me away. I mean, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 H alpha regions.
And those are associated with Barnett's Galaxy.
Yeah, they're all part of Bernard's
And
Galaxy.
that's your fingerprints on the film.
Imagine what their night sky looks like. Well, probably poor because it doesn't have a lot of stars, but the H alpha, it's going through some kind of starburst right now.
Right.
And those are churning away new stars.
And by the way, it's identified as a barred spiral irregular dwarf.
Right,
I know the bars, I believe there was one here and one kind of up there, that's my guess.
correct. The bar goes straight vertical.
Yeah. And then those are side
And
going out from the
there's
bar.
faint stars off to the right and off to the left on top.
Fabulous.
But I just think it's interesting with all the H alpha.
Okay, and then we have Doug's picture. You can still see those areas, like star forming areas in this one. And Doug, go ahead.
That was shot with my camera with the extended red response, and those hydrogen galaxies aren't showing very red here. I don't know.
You can still see them though, that's pretty cool.
Oh yeah, they're still there.
And again, we encourage, I know Roger stopped doing this Observers Challenge online now, but we still encourage members of the club. One thing he commented on is how this club has embraced that program, so we do encourage you to get out there and do images or sketches, whatever of those. And the challenge for next month is M2, Messier 2 in Aquarius, and we got Doug Paul's preliminary image. I know you're going to get a better, closer image the next time around, but this is the one coming up. I think it's, what's the magnitude on that? I think I might have written it down, did I?
It's
Is
pretty-
yet, I think it's around 10th magnitude? No, it's got to be brighter than that.
It's brighter than that.
You'll see this in a 50mm finder scope.
Yeah, it's brighter than 10th, definitely, yeah.
Yeah, it's a fabulous globular cluster. You know, if you
Seven or eight, I don't
do
remember.
a survey of globular clusters in the fall skies, you'll notice that each one sort of has its own sort of unique look to it, its own, I call it its own personality. Whether you start at 92 and 13 and you go over to, you'll get 5, you grab M15, M2. Each one looks just different enough to make it really sort of interesting to do a kind of a survey of them. And those are some of the showpiece galaxies, globs in the sky, where you can, with a medium-sized telescope, you can actually start to resolve quite a few stars in those clusters. The ones I mentioned earlier in Delphinus are just going to look like a little gray spot in the sky. But these showpiece objects, fabulous. M2 is a beautiful, beautiful globular to look
It's
at.
very condensed in the center.
Yeah, it's a very condensed one. Yep, very nice.
Oh, good, okay.
Well, here we are with our September and October schedule for our observing schedule. Late in September, these are all centered around the last quarter moon and the new moon. But then Glenn and I, I'll go back one more, we had been talking for a while now about having a member event during the late October or early November weekends at the clubhouse. Where, Greg, why don't you, this came up out of Chinese food one time. I was too busy eating to know what we talked about.
Like I think full young all over this.
Oh, is
thing.
it?
No, we're planning on, tried to start one of these years ago, and it never happened because I think winter, we were going to do the different seasons. And we did the autumn, and I remember that. I remember, in fact, Chris, you were one of the members at that time. But then I think something happened in the winter, so we just kind of dropped the whole thing. So we wanted to pick it up again. And this is basically for newbies. If you have no idea what's going on in the sky, it's going to be an autumn, kind of an autumn introduction to the sky. And I picked the dates. Let's see if I've got it down here. October 25th to 26th, that'll be a Friday and a Saturday, with a backup weekend of November 1st and 2nd. That puts us somewhere in the middle of the fall, so you're going to get a nice view of those autumn constellations and stars. And basically, we'd start with identifying the major stars and constellations in the autumn sky. Then we'd invite everybody to bring binoculars. And you can take a look at some of the nice autumn sky objects that you can see with binoculars. A lot of people will be amazed to find out you can see a galaxy with binoculars, of course, being the Andromeda Galaxy. And I've got tentative dates for the other seasons. Fingers crossed we get the weather to cooperate.
We just thought it would be a nice way to get people out and looking at the sky and objects that you really don't need a big telescope to see. Because not everybody has access to, 25-inch telescope, although we'll open it that night, on those nights if you want to look through it. But I'm going to probably bring a 3-inch refractor just to see what I can see through my 3-inch refractor. Just a small scope star party, and it's not just for newbies, it's for anybody. I just think it would be nice if we could get more folks to come to the clubhouse and do some observing. So we've been talking about this for a while.
Yeah.
And we'll see if we can put it together. And of course we'll be careful with all of this, and I'll explain more about that when we talk about the star parties. But
that's the thing, we got to be, you can overdo it too. I was thinking, maybe we'll go back just a second here. We go back up, okay. Anyway, the small scope scavenger hunt, Rich and I are going to work on that too, but that might be something we want to do in alternate years, because I think we want to do autumn, winter, spring, and summer, the 4 seasons for beginners. And that might get in the ways if we try to do a small scope. We're thinking on alternate years, we would do some type of scavenger hunt like they do at Stellafane. Maybe something with binoculars, something with telescopes. We plan that, I would say, for next year. Rich and I'll go back to the Chinese restaurant and fight that one out.
anytime, I'll go anytime.
And we did talk at the picnic about Astro League. Now, this club used to be members of Astro League, not anymore, because we don't have that many visual observers. But how many of you here are in the Astronomical League? And what I like is they have observing programs. Now, some people they go out and aimlessly look, and then after a while they just lose interest. I'm one that likes some type of a focus, and I did with the Messier catalog, and I did it with the double star program to the Astronomical League. I just recently did their variable star program. So we talked a little bit. That's another thing I have to work out when we could do this, but we're thinking of a seasonal thing. And I think, who's it, Joe? Like the guy that does the carbon stars so much, Joe Henry?
Oh, Joe Henry.
And we were talking about the Carbon Star program, but we'll see how that goes. But that's another thought. We'll come up with that a little bit later on. And finally, there was a scavenger. We did that. So I think we're all set with some ideas.
One of the things, Glenn makes a good point, to have a reason to go out, Roger obviously calls it having purpose. That's why he especially liked his observing challenge. He'd like to do it himself. Because on the night where you don't feel like going out, or something's on TV that might lure you away from the sky, having a purpose to go out and observe the challenge, or try to see the challenge, or maybe it's to go find that little gem, or whatever. It just gets you out under the stars, and you never know what the sky is going to show you, right? We've been treated to auroras this summer. We've had some great luck with auroras, and you just never know. You never know what you're going to see. So it's reason to get out there and just enjoy this hobby. And I know that we're going to cater this to the visual crowd, but images as well. We can, we'll publish our little list, and we can do little mini Messier marathons. We can do whatever the membership wants, just to get folks out there observing. It's a lot of fun. And there are other people on the field. You can go and look at all different kinds of telescopes, or through the big telescope if you want. That Pi Finder that was mentioned earlier is a nice addition to the 25-inch. We're hoping it'll make it easier for everyone to use the telescope. It's a push-to system. You literally tell it. I've never seen it initiate itself, but it initiates itself, knows exactly where it is, what time it is, what the sky looks like, and then you say, I want to look at M2, and it'll tell you how far to push the scope one way and how far to push it the other way, and there it's in the finder scope, and you got it. It's a nice little tool.
Arrows. It says, push this way so many degrees, push to the left so many degrees, push up or down so many degrees, and it updates in real time until you get to zero.
Very
And
nice.
so then you're pointing roughly at the thing, and you can find it through the finder.
You know where it gets confounded, Alba? At the zenith. I put it through its paces at the zenith, and it was like, okay, go 85 degrees. And I went 85 degrees, and I went, okay, now go back 120 the other way. So I go back 120 the other way, and I go, wait, no, go back 45 where you were before. It just, you know, Dobson's hole up there.
I can understand why that would be. I can understand.
I can
that,
understand it
because
also. I thought I would tease it and see what it would do.
Yeah.
I was gonna throw in one last thing.
Sure.
The Messier Marathon, we haven't done that in a number of years, and not that many years ago, I did a thing for Astronomy magazine, the Double Star Marathon, so we're trying to see if we can get any of those going again in March, if there's any people that are still physically able to get out and stay up all night. And we might do a mini Messier Marathon, see how many you can find, and the Double Star, the same thing, up until midnight, so.
Yes.
And I think
It's
we
for
are
fun.
set, right?
It's just, well, I'm gonna step and do the star party thing.
Okay, well, I'll just say
You
again,
can step if you want.
keep looking up. Oh, okay, we need
You
the
can
looks
stay
here,
up.
we need the looks.
Stay out here.
All right, so next is our speaker. Joe Dechene will present his approach to telescope making using his latest Stellafane entry as an example. This telescope is a binocular rich field telescope using 100 millimeter objectives built with an intent to scan the sky and see extended objects not easily visible in most telescopes. Joe has been making telescopes for many years and has several Stellafane awards for mechanical, optical, and craftsmanship. He has an article in Sky and Telescope on plastic gears and an article on valence rates. Over to you.
Thank you. All right, any telescope builders, any wannabe builders in the room? All right, show of hands, all right. So I was going to make an 8-inch binocular telescope. That was on my plan. I bought a couple of pieces of glass, and I saw this article in Sky and Telescope. But before I go there, the objects you see in the background, the astro objects, are the kind of objects that either you can see very well through this type of telescope, or objects that were called out in the Sky and Telescope article. So instead of building an 8-inch binocular telescope, I saw this article about someone who made over-under binoculars. I thought, wow, that was nice. Then I saw Jerry Oltian's comment on it. And holy cow, what an incredible view these scopes provide. And he adds, objects that require study in my 20-inch scope stand out easily in these scopes. And he says a bunch of other superlatives when he's describing this type of scope. And I thought, by golly, I want to make one of these telescopes. I want to see the things that you can't see in regular telescopes. The advantage over a telescope, you're using both eyes, it's Rich's field. And the advantage over binoculars, I can use good eyepieces, I can use nebula filters. It's a rock steady view, it's very comfortable to observe with. So it's a lot of advantages that you just can't get with a 100 millimeter pair of binoculars or a telescope. So these are 80 millimeter telescopes, and I couldn't find 80 millimeter lens. So I found a 100 millimeter lens, but I'm going ahead of myself. When I start with a telescope project, I start with the why. Why do I want to build this? How do I want to use it? What do I want to see with it? And this is sweep the sky, wide field with ease in awe. And I want to see the things not readily viewable in regular telescopes. That's the start of the telescope project, and everything contributes to that use case. So that's the number one point of view, is you start with the use case. The why do I want this telescope? To support the why is a set of requirements. And I have a certain set of requirements that I generally have for my telescope. My first real good telescope was a premium 8-inch Newtonian telescope. And And it was expensive. I bought it used. The thing probably weighed more than me. And when you focused it, it jiggled just while you were focusing it. You couldn't use it for photography. And I decided when I make my own telescopes, I want them to be rock steady. I want them to be photography capable. And I want them, because now I have quite a few telescopes, I want them to store compactly. I want them to travel well, store compactly, and I want them to be rugged for public observing. Some of these requirements, as you know, kind of butt heads with each other. You know, I want it rock steady, but I want it lightweight. I want to be able to store. I want to be able to set up quickly. I want this to be really my impulse scope. That hey, something's out tonight. I'm just going to take it outside and set it up quickly. This is going to be the scope. Anybody notice a requirement that's not on the list? Give you a hint, has to do with Stellafane. When I was young, I won a couple of Stellafane awards, and I had a friend say, Joe, design me a winning telescope for Stellafane. And, you know, I asked my question, well, what do you want the scope to do? What are you going to do with it? What, you know, it's exciting, I want to do it. But he didn't really have, no, just a winning telescope for Stellafane. And, well, no, that's not the way I approach it. This is a scope made for me that I want to use and enjoy. And if I solve some of these contradictory problems with the requirements, the definition of the telescope, and the Stellafane judges take notice, that's good. If I design a telescope saying, I am just going to do something to win at Stellafane, I run the risk of just doing gimmicks. And I don't want to do that. The scope that I use it. And just to put icing on the cake, the previous year I built a 6-inch f4. Didn't win anything at Stellafane. I used that scope all the time. I love that scope. In 2010, I was frustrated with flashlight batteries. You know, the astronomer's red flashlight always go dead when you need them. So I built forever flashlights. I still use those flashlights day in, day out. Didn't win an award, but for me, it solved a big problem. So that's what I really care about when I approach a telescope. It's great to get Stellafane awards too. It's also good. I believe I'm going to hold the presentation for a moment because I want to show how this telescope works. Because I'm going to go into some technical nitty-gritty detail. I'm not seeing anything yet. So this is a cutaway view of the telescope. This is Tinkercad. This telescope is complex enough where I had a lot of potential for interferences. So I did the model in Tinkercad, and just, you can see the right lens. This is the left lens. The right eyepiece and the left eyepiece. Now on the actual telescope, these eyepieces can be as close together as 60 millimeters, and there's an adjustment that can go out to 70. The lenses are 100 millimeters in diameter. I just have a simple right angle reflection in the telescope. For me to maintain that spacing of 60 millimeters between the eyepieces, now I have to mash the lenses together. That's a good idea, right? No. So to solve that problem, the same way that Frank and Robert did, is I move the left lens down and maintain that 60 millimeter to 70 millimeter spacing. So that's good. But what you get when you do that, now that I've moved the left lens down, you can see the vertical distance from the left lens optical system up through the right scope, essentially, is greater. You see that distance is greater. And because it's a binocular telescope, the lenses must be the same focal length. So to compensate, I pull the left lens back until the focuses reach at the same point, the same vertical height. Is everybody clear on this concept? I don't want to fly through. Mario?
I just want to point out as a mechanical judge, this one innovative component because it's brilliant.
Oh, thank you. Everybody's good.
Are the secondaries the same size?
No, that's a great question. That's a 2.14 secondary. By the way, that secondary is interchangeable with my 6-inch f4, if I ever want to do it. But I haven't interchanged them. I could do it. That's a 3.1. That's a leftover from a 14-inch project. So great question. It is, and the 2-inch I bought specifically for the project. The 3-inch I have. Good question. These are the these are the basic adjustments. So this wheel here, which is in orange in the picture, adjusts the spacing between the eyes. Helical focus is here. The filter slides. There's one, the other one's there too, are integrated, and you can see I can just pull them out and push them in without losing them. For me, that was a requirement. These knobs here align the images left and right, up and down. You do it in that order. Generally, you don't need to touch them. The lesson learned for me is to hide those knobs. So when Stellafane started messing with those knobs first, the knob here is just simply to move the scope up and down. Everybody clear on the basic adjustments? Did I miss anything?
When you change the IOC, is that changing, that's changing the optical pad slightly? Are you moving the mirror below it?
So that's a very good question. I'll get to that, but the simple answer is everything moves together and moves as precisely as I can.
Very nice.
Yes. Very good question. Let's see, my showing azimuth handles. So these handles you can use to move an azimuth, and also as I use them to hold it when I'm setting it up or I'm moving it from one part of my driveway to another. Everybody clear on the concepts? I'm going to go back. Now as a review, we started with the use case. We listed the requirements. Oh, one more concept picture. The hockey stick started with this telescope. That's my 6-inch f4. That's my shapeshifter mount that I put in for 2019. If you want to hear about the hockey sticks, that's that presentation. But the beauty of this setup is this one can be connected to the camera, can be taking pictures all night. Well, I use this one to scan the sky. So this is great. I can be twice as effective, twice as productive.
Finder?
What's
A
that?
finder?
Not for this one. It's pretty wide field, so I'm generally pretty good at it and getting better. At
What's the field?
2.4 degrees with the eyepieces I have. These are 13 millimeter, 1.25 eyepieces, but the barrels are 2-inch. If I ever get rich, I'll get some nice 2-inch eyepieces and put them in. Good question. One more. Oh, I use this mount for some of the feasibility. So just so you know the differences between the two telescopes. Everybody clear on this? All right, let's jump back into the design process. I took a little detour. So the Article and Sky telescope had 80 millimeter lenses. I was able to find, I couldn't find 80, I was able to find 100 millimeter lenses on surplus shed. And as soon as I saw those, I bought 2. I said, I'm gonna build this telescope. This is as close as I could get. So I bought them. And I want to evaluate them. Now at the Stellafane swap meet, I once bought a couple of 50 millimeter lenses for finder scopes, and I built this nice carbon fiber finder scope around it and use it. Find out that the lens is no good. I had to buy another lens and do a little bit of modification to get it to work. There's a lot of value add on this. I want to test the lens first before I embark on that journey. I want to know the focus distance, and I want to know how sharp and the color correction. And by the way, this North America nebula was taken with one of these lenses. So how did I do that? So I actually labeled that. So this is a really quickly, crudely built telescope where it says temporary test scope, November 2022, to evaluate the lens. Big item for me is a good lens, and what's that distance, what I call the physical focal length from the back of the lens, or the mechanical focal length, from the back of the lens to the image plane, because that's what I'm gonna base all the other measurements on. So, there's another view of it. There's the front view, I think you can see it, it doesn't show up on
I
mine.
see.
Yeah.
It's a doublet?
Yes, it's a doublet.
Got it, I see.
And then I take those measurements and I put them in the spreadsheet and get that distance from the back of the lens to the image plane, and then subtract all the components, the adapters, etc., and test it with a variety of eyepieces just to make sure I have that distance right. Because now, once I have that number, that spreadsheet like feeds into the rest of the spreadsheet and becomes the basis for the rest of the telescope. And so I can go with confidence that when I cut the final dimensions, it's going to reach focus.
Got it.
Everybody's with me. Sketch out the concepts is really the next thing. I'm dealing with a lot of contradictory requirements. Remember when I defined the requirements, some of them kind of interfere with each other. So go through various designs, and I did this on Tinkercad. It's really a kids CAD program. It worked. This is in July of 2023. You see I had some differences. I had handles. I actually did do the dovetail on this. Just getting the details on the optical trains to be right. The filter cantilever is actually a later addition in the design, but before I cut any wood. The initial tripod in December, the overall concept of how this is going to mount. I made the legs a little bit longer. I was doing tests with this on the counter. I had the top part built, and then, kneel, stand, and try various heights. Realized I wanted to make it a little bit taller. Those of you who came in late did not see the requirement is that the legs fold up over the telescope for storage and travel. This makes life a lot easier because I have quite a few telescopes at home, all pretty much homemade also. So we're clear, we sketch out the various concepts after we've defined the requirements and try to solve as many problems as you can. Side handles.
I have a question.
Yes.
Was one of your requirements that with 100mm lenses, you had to get down to a 70 and 60mm interocular without prisms or other mirrors?
Yes, I wanted to keep to that over-under concept in a single reflection. Absolutely. Tinkercad for me, it's great for showing interferences, it's great for showing, how everything's gonna lay out. For me, not great for giving to the third decimal place just exactly how it is. The next scope will be more mechanically CAD program. The one you showed me, Corey. Yeah. So I use a spreadsheet to calculate everything to 3 places and cut everything as best as I could to 3 places. There's a lot of tight-fitting components inside to keep it rigid. Yes?
And you would use wood, which is going to have a lot of differential stuff having to do with humidity and...
But the dimensions that expand and contract, I try not to make that critical. The critical dimensions, I use the grain length. Good question.
Thank you.
There is actually, I did some parts of it in one of the seasons, I actually made a little bit of like the lens thing, a little bit oversized, and then some. I said, I want to make sure I don't squeeze my lens. Question.
You use marine plywood?
This is Russian birch or Baltic birch. I love this stuff. It's lightweight and strong. We come to the really the fourth part of how I approach a telescope is the risk management. There's some new aspects of this design, and in this case, the interocular adjustment was the most riskiest component. And because I usually on a telescope, I like to build temporary components, build and test, build and test, build and test, and refine until I get it just the way I want it. This one was a little bit different. I had to test the intraocular adjustment and then spend 11 months. So how did I do that? These are the requirements for it. It can't bind. That was for me, you know, the opportunity for this thing to bind, to be tough at one end and easy at the other. And the other is it had to stay parallel. So how did I do that? So this is the feasibility test. Note the date, December 2022. So this is really early in the design. Once I had the basic concept sketched out and said, will this actually work? So on the left is the so to speak, the micrometer adjustment for the fence in my table saw. So I said, this is useful. I clamped it to the side of the counter. On top here is that test telescope that I used to evaluate the lens. So that's resting on top. Underneath it are two single action drawer glides. Those provide the actual track for the motion. So those are attached to a piece of plywood. I have a dial gauge down in the lower middle, and there's one up above that's not visible in this photo. And then underneath the weight is a spring that's pushing the whole thing back against the carriage bowl. So without the micrometer action, just make sure I can get it to be smooth. And then with the micrometer action, go back and forth and make sure that the dial gauges are reading exactly the same amount. And that means when I adjust the intraocular spacing, I won't need to adjust the X and Y alignment at all. For me, that was absolute. I had to nail that before I proceeded on with the construction of the telescope. I want to let this sit for a while. Is everybody aware just how this experiment works? Does anybody have a question on this experiment?
So the crucial thing here is just to make sure that you have the slides parallel, I would think.
Right. Must make them parallel, that's one. Yep. And then the other is, there can't be play in it. If there's play, and let's suppose I push on this and this end goes and this end lags behind, that's a showstopper.
It needs to be rigid.
Yes, yeah, it's got to be rigid enough and not have play and be parallel. Because if there was play and it would need to be parallel, the slot would take it up. But I didn't want that. By the way, when I did build this scope, I had like a reference piece of wood that I used to just make sure that actually everything was set parallel before I glued those in.
Hey, Joe.
Hi.
It's Charles right here. Did you say single action drawer slides?
Single action.
What does that mean?
So single action has this outside component. I don't know if you can see on the screen, but the visible component that you see on top is the outside glide. There's an inside glide that's attached to, one's attached to the drawer, one's attached to the cabinet, essentially. And then there's essentially a track in the middle that holds the ball bearings.
Okay.
In a single action drawer glide, it's simpler. You can pull the drawer essentially halfway out, and that's it. A full action drawer glide, a double action, has additional track inside that cantilevers out.
I got it.
And you could probably use that. I did not. I had a single action. The danger about a double action is now you've got more intricacy in there, and less bearing, surface area.
For long travel, generally.
And you don't need that much distance anyway.
Absolutely. I only need 10, 12 millimeters at the most. For me, it was 10.
Thanks.
Question?
What's your intraocular distance?
70 to 80. Excuse me, 60 to 70.
Your personal?
Oh, I'm about 65. So it's right in the middle. So, good question. Any other?
57 here won't fit.
Try it out. 4 millimeter plus exit pupils. Anybody else? Nope. So this work.
Yeah, so I have a dumb question.
Yeah?
So everything is moving,
but I only see 2 holes in the outside of your enclosure here, and so is one of them larger than the other to sort of? So as,
You're referring to the front, I think.
yes, exactly. So as you move it,
You can see there's an entire telescope inside here, an entire, you'll see this on a future slide.
so that's kind of a 10 millimeter oval right there. So
Yes,
the
that's a
object-
10 millimeter
I
oval.
see, okay.
Yep, good question. Flash. All right. This passed, so later on, I cut the tracks to length. All right, this is the slides for Mario. I'll show Mario. This is the view. So now essentially you're looking at, just make sure I don't drop the eyepieces. You're looking at this assembly upside down, sitting on a bench. Actually, I have that right. Flash. Yeah. That's right, you're looking at this, so it's essentially this mechanism minus the walls, sitting on a bench. This panel here, where it says outer scope top, is here. Inner scope box top, you don't see it on the finished product. But that's essentially the top plate of that scope. You can see the tracks, the drawer glides. You can see the interocular adjust wheel, which is anchored to the outer scope. You can see a little bit of detail. In this case, I cut 2 pieces of aluminum so I can put the threads a little bit off from each other to take out some of the slack. And then the aluminum floats in a mechanism on the movable plate.
Where in this picture is the glides? I'm sorry, I'm not seeing it.
Right here. So where it says outer scope top, you see the metal, that's right next to it, that's one. And the other is way up at the top, where it says inner scope box top, you just pass the eyepiece holes.
I see.
Right? That's where it is. November 2023, it's 11 months of working on the scope before I can test it for the first time. So this is why back in December of the previous year, I wanted to make sure this worked. Because I'm really undergoing some risk on here, and that experiment proved it out. Is everybody with me? The next riskiest item for me is the focusers. They have to be narrow. I want a 2-inch focuser when I do get those 2-inch eyepieces. And I want to get it as narrow as I can. I was able to get 60 millimeters. And I want to juggle the focus, a close focus distance, and the clearance to the filters. So now I'm kind of juggling with Tinkercad and the spreadsheet. How can I get a good range to look at birds, etc., and do everything else that I want these eyepieces to do? This is the finished product. So this was in January and February of 2023. All I have at this point is that experiment that I did on the bench in these focusers. This was really the first item actually built for this scope. You notice it's 6/10 of an inch more depth on the right focuser than the others. Anybody know why? This will help. The right focuser is attached to the inner scope, which is the 6 millimeter plywood, about 3/8 of an inch for the glides, and then reaching down onto the top of that inner scope. So it has to have that extended base to make the overall eyepiece heights level. So I had this for quite a while. This is basically how it works. There is a 2-degree offset in the ball bearings that provide the helical focus action. So now that I have this, I know how narrow I can get, I know how wide I have to get. I can set the dimensions on the overall width of the box, the width, the inside dimensions now start to firm up. Now that I know I have these in hand. Risky item, handled, right? Risk mitigated.
Now, so the way in which this helical thing works is you're running on these ball bearings on just bare metal.
The aluminum, the contacts of aluminum.
And that means that something else is.
Nylon screw.
Somebody's pressing down on the top of the focus tube.
Yep, that's where the nylon screw comes in handy. You can see it on the bottom of these.
So on the bottom of the screw is scooped out or something? Or
Nope, it just presses in.
Okay, it's good enough.
It works well.
Amazing.
Yeah, I actually used this for a 6-inch f8 scope, a helical focus, and it worked very well. I was pleased. Any other questions?
Crayford focuses, essentially. They're Crayford type focuses.
They're helical. I don't want to call it Crayford because it is different enough. But yeah, there's no rack and pinion gear on this. For me, the objective was to keep these as narrow as possible and still make it mechanically strong. My scopes generally, I don't go for ultra lightweight. I go for lightweight but still rugged. I want it to last for more than 20 years. The scope I built in 2002 is still running strong. The next riskiest item was the filter slide. Now this was, I was going to screw the filters into the bottom of the thing, but that, remember my requirement. I want this to be that impulse scope. You pick it up, take it outside and use it. And just having the filters always there is very handy. And so there's a little bit of complexity in this to make this work. And I wanted the filters to stay in the telescope. I didn't want something you pull out and then put somewhere and lose them. So those were the requirements. This is the initial build here, I have a date, April 2023. I'm jumping ahead on this picture because this one shows a little bit of the concept. So this is the back end of the inner telescope that's behind the right lens, part of the right eye. The filter on the right here is anchored to this wall, to the wall of that inner scope, which means when I do the intraocular adjustment, the eyepiece, lens, diagonal, and filter all move together. Relative to this scope, it all stands still, but relative to the outer scope, it all moves together. The filter on the left, I could have went easy and just had it move 10 millimeters off to the side, but it was fairly okay to make the cantilevers. This one is actually goes through the walls of the movable telescope and is anchored to the wall of the outer telescope. So when you do the intraocular adjustment, the left filter, the left lens, the left diagonal, the left eyepiece all stay in one spot. And then the right, all of this moves together. So the filters always stay underneath the eyepieces when they're engaged.
Joe, you say you've got click stop in these filter slides as well.
Yes.
Do you have it turning a knob or do you just pull them out by hand?
Just pull them out. So let me go over to click stop because I had, actually, I'll be right there, Steve. The other thing with the filter is the interference potential with the light cone. Again, I'm playing with the overall dimensions of the scope. It's very close to the right light cone. The left one has plenty of room. I don't have to worry about it. So the right filter actually has a little bit of a notch in it to give me a little bit more clearance to that light cone. Just the tight dimensions to work in to make this overall work. And then, Steve, come back to you. I initially had click stop just by the spring action of the wood. But it's one of those things that I'm forever testing, playing with, using. It's good, but it's not good enough. Finally, I broke down. I added some extra springs right underneath the click stops to give it a much more crisp feel throughout the range. The one on the right it's very close to the diagonal. So you can see I whittled that end down as close as I could to provide that space so the diagonal can even adjust a little bit, over too much just to make sure I have some room. And with that, I have some good action on the filters.
I've had 2 sets over the years and they've always gone out. The quick stop stops working.
Okay.
It's,
Knock on wood with the spring, hopefully it should be
you
good.
probably have stronger springs and it's a little more of a positive grip. Yeah, that's
All
good.
All right, I gotta keep an eye out for that. Any other questions? So most of the risk items are pretty much behind me at this point. Now it's just the devil in the details of it. This is passing the light through the requirements. This is how do I get the light cones to harmonize with each other, so to speak, and not interfere. These are the requirements. Again, I can't have one scope flexing inside the other or them flexing with respect to each other. There's opportunity for that to happen. I can't have the diagonal mounts flex. So these are the things now that I tested, build and test as you go along. This is the basic concept. This is a dry fit, just to show the concept. This is the inner scope that's inside that you don't see, and it's just a dry fit, just to show. And what I did on this case, I could have made it narrow, but instead I made the scope wide to encompass both light cones, and that way I can minimize the structure in between the two. So this is a dry fit. By the time now in July, I'm really cruising on the construction of this scope. This is the Tinkercad of the back end. I removed the back end components. I've hidden them in the CAD. And you can see the left light cone actually passing through the lower part of the box on the right scope, through the filter, and then through the upper hole into the focuser. So just get that all to work. So that's the basic concept, how the light paths go through each other. And you can see there's a little bit of aluminum I have to keep the light cones separated, so I don't have any interference between the two. Let's see it. This is, now I have the walls of the right scope built. I have the top of the left scope built, or the outside scope. I am getting really close now where I can test it. This is November 2023. I'm really on the home stretch of construction. And let's see it. November, a full 11 months after I do that feasibility test of the intraocular adjustment, I have my first binocular light test. And at this point, I can test. And the way I build telescopes, test, go outside, observe. In this case, I'm observing the neighbor's light over their garage. Go back and see what worked well, what did not work, and go improve it. And continue on that cycle until I get the scope as smooth and as working in the way I want. So this, for me, was a very big item.
What was the first thing that didn't work?
So actually on this, what I found out on this was the diagonal mount that I had for the 3-inch diagonal, I was off by the thickness of a wood. I forgot that I had a thickness of wood. So my images were, let's just say, I could get the images aligned, but one of them was not collimated the way it should be. Genuine mistake.
Of course.
I made a new one. I said, I'm not gonna rework, I just made a whole new diagonal mount, taking into account that 6 millimeters.
How did you collimate it?
Oh, that's a very good question. There's collimation screws for the lower scope and then for the upper scope is here.
So is that moving the mirror?
Yes, just like a Newtonian telescope. It's the exact same arrangement that you move in the mirror. I don't know if I can try, I might not have it. The right scope diagonal is mounted on a plank, like a diving board. The adjustments are mounted at this end, and there's a pivot, a rod at the same pivots. It's held in place by springs. And then this knob here, the left-right adjustment, moves the end of that plank. So what I do is I get the plank where I think is a good neutral position, and then I get this diagonal collimated. Then I'm good to go. I can make the minor adjustment afterwards for the left-right image alignment.
But in terms of how that diagonal, to make sure that the diagonal is collimated with the individual scope as well as between the scopes.
Yes. So each scope is pretty much an independent scope. That right scope has its full diagonal mounting, all writing with that the right scope.
But you have to collimate it to make sure that it was actually at 45 degrees.
Yes, absolutely.
How did you do that?
It's got the 3 screws in here, just like a Newtonian reflector, a Newtonian diagonal. It's pretty much exactly, in fact, it's a replaceable diagonal by Newtonian. It is.
Adjustment to the objectives for tip tilt?
The objectives are fixed. I just made those as mechanically as fixed as I could and didn't bother with it after that.
I guess my question is visually, how do you know that it's collimated?
Oh.
You said how you adjust it, but how do you know?
The initial adjustment, I have a Cheshire eyepiece and a laser.
Okay,
And
that's what I was.
Okay, I'm glad I understand. Yeah, it's conventional, just like a Newtonian or a refractor. You do it with your Cheshire eyepiece, you do it with your laser collimator, and you get each one right.
Okay.
And then hopefully they're really close. Mechanically, you know, everything is as close as I can possibly make it. It's just like a little bit of tweak at the end. Good question. Any other? So, at first, this was just going to be a dovetail mount on that original Selkie tripod, the shapeshifter tripod. But at some point, I decided this was going to get its own tripod and mount. The requirements of the tripod: steady, lightweight. I can pick this up, move it to a different part of the driveway, and fold upwards, as you saw in the CAD drawing for travel. The initial test, of course, was with the Selkie. So the tripod wasn't built yet. And so here, can't see it on this screen. I am out, this is mounted as a dovetail on this side in the picture, and it's just attached to the saddle of the Selkie mount. And then I'm using it. It works well, it's steady. But one thing that you can't really see is too low. The Selkie can go higher, but that takes away from the instant, I just want to like impulse use this. So I decided new mount, higher up than the Selkie. But it did provide me some valuable data in terms of the optical assembly, anything I needed to do. Just like the other mount, it's a hockey stick mount, strong, lightweight. I get sticks for free because they're broken. The blades are broken. I play hockey. Those of you who've seen my Selkie presentation have gone through that. Each hockey stick is a little bit different in terms of the inside diameter and the radius. So the wooden plugs, this is made out of that birch plywood, is cut a little bit different. Each one is measured individually and numbered. And these are the top plugs for the tripod sticks, essentially, to go into the base of the telescope. This is first light with the tripod. So in this case, the top ends are built, but nothing on the bottom. The bottom is just a piece of shipping tape holding the legs together. But this is doable now. I can still take this out, I can use it, I can test it. Just don't kick it, right? But I can really, continue to run this through its paces and test and refine. This is during this. Where am I? Oh, okay. Skywatch Portable. This is a ladder cart on the right. So I use this for observing. When kids want to observe it, they can climb up the ladder. The ladder cart has wheels on it, and then this just bungee cords to the ladder cart so I can wheel it around. So it makes it one trip. For me, that's been a big thing for me on telescopes because, you know, I work. By the time I get to the star parties, you know, I'm parked 3 blocks away, and I don't want to like make 2 trips to observe. Storage compartment. This is this item here that's underneath. So these are the requirements. These requirements came a little bit later, and you'll see why. This is in February. I got the tripod, you know, enough of it built and running, and then I have a lot of trees in my driveway. I live in Nashua. Pick up the telescope, move it to another part of the driveway to find different objects to see that are not blocked by the trees. And one of the legs overfolded when I picked it up and put a strain at the joint between the top of the tripod and the base. And I said, oh, this is a no-no. This is found by testing that I find this condition that I need to find a way to make sure that these legs don't overfold under each other and interfere with the mount. How do I do that? See if I can animate. There we go. So this is the storage compartment. This is actually the late addition after I had that failure in the driveway. What this does, it makes a handy dandy storage compartment. Well, you notice the compound angles of this are matched up. Let's see, right there, you can see like the little angles. When all 3 legs fold to the middle, they're going to contact that storage compartment. They won't fold anymore. This is underneath, so this is folding to a common point underneath. And that's it, the legs won't fold anymore. And that way I won't get any more strain on the upper joints on that from happening. Is everybody clear on this concept? This is something found in testing. Starting to see some nods, okay. That's the basic concept. Start gluing it together as a storage compartment. One more picture. The eyepieces store in here also. I just made little 1.25" storage areas for the eyepieces. Here I am. A month later, observing, now I have, you can't really see on the screen, I have the storage compartment, I have the leg spreaders, I have the bottom feet, pretty much done by this point. So that at least they're all operational. I can continue to observe and test, refine, trim, tune, whatever I need to do. Any questions at this point?
Great. Do you have any kind of a do problem?
Less with one than the other, I would say.
This goes over the upper right lens when there's dew.
Let me see that picture.
That's what this is for. I also have an eye shield that goes across here on the bottom. These 3 velcro pieces hold an eye shield to keep the myriad of streetlights where I observe, keep them from reflecting in the eyepieces. Any other questions at this point? Yes?
Use it for solar at all?
No, I don't want to go blind in 2 eyes.
Well, I mean.
No, I decided in this scope I'll never do solar with it, just for that reason. The 6" f4 has a solar filter, so I'll use that one. Figure out which eye I want to sacrifice. I'll probably use the camera for it.
What type of glass is it?
Glass? Yeah, achromatic glass, as far as I know. And the color correction is actually pretty decent on this. By the time I get to March, I pretty much have a good functional telescope. A few more minor tweaks and things to do, but I'm pretty much running. Publix, hi.
What's the focal length of the lens?
450. So it's a good wide field, and to do it any other way is difficult. I was thinking about that. If I had to use a reflecting telescope and a bino viewer, get the same wide field, at least with 1¼ eyepiece, I'd be dealing with a 6-inch f3 and figure out how to handle an f3 cone with a bino. It gets difficult. This is actually a real sweet spot in the telescope in the world. Telescope world. Is that right? Public sky watching. Our own Corey, looking at the moon in this case. So that was Westford in April, Goffstown in May, and then Stellafane in August. Somebody told the bus driver, this is the bus driver who drove the bus at Stellafane. Someone told her, you gotta look through that binocular telescope. So she parks the bus. She goes over and she comes and takes a look. I'm really looking at the trees, at the end, and she says, I'm coming back next year. So who knows? We may have an astronomy convert, so that's good. That's pretty much my journey in terms of looking at the telescope. Does anybody remember, now the summary, what came first? Does anybody remember?
The requirement.
Oh, even before the requirement, the use case.
Oh, right.
Right? Why do I want to build this telescope? What do I want to get out of this? Right? So that's first. All right, help me out. Define the requirements. Right? List out the needs and the requirements. Next.
Feasibility.
Sketch out the concepts. All right, we're good. All right, Corey, help me out. What's next?
Test.
Feasibility test the risky items. Right? If the risky item doesn't work, if it says, no, this won't work, I have to go back up a step, don't I? And re-sketch it out and find something that does work. Next.
CAD.
No, sketch.
Some sketches and models.
Test, tweak, test, tweak.
Test and improve, test and improve, test and improve. By the time I get to Stellafane, hopefully the paint's all dry. I tell you, I want to make sure that this thing is pretty refined. Last? You got it, nailed it. Thank you, everybody.
Take it outside and set it up for it?
Maybe, huh? If you want to look through it, it's past my bedtime, but I'll set it up. Let's take a look. T. Corona Borealis, maybe it's still out.
Yeah, great.
The rotation, that's just on a regular bolt and we had.
3/8 bolts. The same thing I use, by the way, to hold my 6-inch Teflon pads, and I use hobby plastic. It works really well. I didn't include a picture of the base, but just I use like a 6-inch putty knife to spread carpenter's glue, and then put the plastic on and press it. Yeah. Fortunately, it came out really nice the first time, so that was a tough one to rework. Any other questions? Yes.
I live in an apartment and I'm used to doing things like cutting with a hacksaw and hoping the wood is on the same planet as a right angle on a straight line. How much of a machine shop do you need to do something this intricate?
You know, I just threw away a 45-year-old telescope that I built, cut with a jigsaw. And you know, the telescope was around for 45 years. It just was no longer in my plans. Not to mention it got a lot of water damage being under a leaky roof. It should not stop you. It is, you know, when you think of the concept, you know, come up with how you're going to do it with the jigsaw. How you're going to do it with the portable drill, and continue on. It didn't stop me when I was young and you know, really constrained in terms of tools. I don't have the fanciest workshop. Now I have a table saw, I have a drill press, I do have a 3-in-1 I can make the knobs on and a router table. That's pretty much it.
It's nice to know.
Yeah.
Mark Helton has his hand raised.
Mark?
Hello, everybody. First of all, sorry I can't be there. I can't be anywhere right now, but it's nice to see you guys. So, Mike, I have kind of a silly question. When are you coming out with the commercial version of this?
Can't afford it.
Yeah. You know.
I can't afford it, you're right, but I tell you, what a design.
Thank you. You know, I think about, would I ever do this commercially? I don't know if I could enjoy building the same telescope again. You know, it's just not me.
Sell the patent, sell the patent.
All right, any other questions?
Thank you.
What's the total weight when you set up?
Let me see, about 33 pounds. Any other? I've enjoyed this very much.
Really nice, Joe.
Share.
That's fantastic.
So, I guess this is the end of the meeting, and the next meeting is October 12th at 8 o'clock. Thank you, everybody, for joining.
That's
Yes.